Hello everyone. So bond energy is defined as the amount of energy required to break a bond. They're usually given in kilojoules per mole. Breaking bonds requires energy while forming bonds releases energy. A reminder that the energy it takes to break a bond is the same magnitude as the energy needed to form a bond. So in a chemical reaction, several bonds are broken or formed, and the overall energy change for this process is calculated as delta H equals energy required for breaking bonds minus energy released from forming bonds. Essentially, it's delta H equals bond energies for reactants minus bond energy for products. Now let's do some calculations. So as shown here, the formula that we're going to use is delta H equals reactants minus products. So you're going to have to use a reference package or textbook or data that you can find online for the amount of energy that is required to break bonds. So let's see what we have here. So we have H2, so hydrogen, and for hydrogen gas, the molecular structure is pretty much H bonded to H, and we have F2, so that's pretty much F bonded to F, and then you have HF. But there's two of them, so I'll draw two of these out. So in the reference package that I'm using, the bond energy for hydrogen to hydrogen is 432. Bond energy for fluorine is 152. And the bond energy for HF is 565. But there's two of them, so we have to multiply this by 2. So this means that you're going to get 1,130. I'll just draw a line here. So for the reactants, if you add these together, the total energy for reactants is 586. So following our formula of delta H equals reactants minus products, you're going to get 586 minus 1,130. After doing the calculations, your final answer should be negative 544 kilojoules. Now, for the next question, we also have to figure out the bond energies. So first we have NH3. So looking at the reference package that I have, NH, this bond energy is 391. However, if you actually draw out the molecule for NH, which is ammonia, one ammonia atom actually has 1, 2, 3 N to H bonds, and looking at our formula, there's 2 of them. So that means that you have to do 391 times 3 because there's 3 bonds, times 2 because there's 2 of these in our formula. Now in terms of hydrogen, so H to H bond, the H to H bond is 436 in my reference package times 3 because there's 3 of them in our formula. When you multiply this together, you're going to get 1,308. And in terms of the nitrogen is actually N triple bond N. In the reference package that I have, N triple bond N, the energy is 941. So using the formula as before, delta H equals reactants minus products, the number for reactants is going to be 2,346, and then we're going to subtract that from the energy gained from the products. So by adding it all up, I got 2,249. Reactants minus products will give us 97 kilojoules. Since this is positive, this means that the reaction is going to be endothermic. And in the previous one, since it was negative, it means that the overall reaction is exothermic. Another way to write this would be, so one, you can either write it at the end of your, on the other product side of your reaction. So this would be plus 544 kilojoules, or it can be delta H equals negative 544 kilojoules. Now for number 2, since it's endothermic, you would have to write it in the reactant side, so plus 47 kilojoules, or if it's outside the equation, it would be delta H equals positive 97 kilojoules.